Welcome everybody. Let us build a program that reverses a given integer without changing its type. For example, if we consider the number 987, our program should return 789. So while doing this process, we should not change the type of the given number, in this case that is 987. So to do so, we want a logic or a principle that to be applied in programming. So we can think that here to reverse a number the mathematics can be involved. So let us use mathematical operations on these numbers and let us build a logic or a principle that to be applied in programming. Here is the integer 987. So the reverse number of that is 789. So in order to obtain this 789, we are going to consider the numbers from the rightmost. So to consider that 7 from 987, I'm going to use the modulo function that just returns the remainder when the number is uh, divided by something. So here 987 modulo 10 returns 7 here, and the next step is to consider 8 from 987. Here we have used the process to consider the number if the number is the rightmost, but here 8 is the second rightmost number. So to make that 8 rightmost, we have to pop out that 7. In order to pop out that 7, I'm using the float division that just ignores the decimal part if a number is divided by something, and that just returns the floor value. So 987 floor division 10 just returns 98, and I'm using that 98 as the considered number as we have done 987 here, and extracting 8 from 98 as 98 modulo 10, and that just returns 8 here. So and then in order to consider 9, I'm going to do the same process that I have done in the earlier cases. So here 987 will be 98, and that just returns 9, and we do not need any further processes. So here we have these numbers 7, 8, 9, and those are the digits of 987. So and we are going to use those numbers by using some mathematical operations on them to make them 789. So in the first case, I am going to multiply that 7 with 10, and that just returns 70. And after returning 70 there, I'm going to skip. I'm going to the second case, and there I'm reusing that 70 which we have obtained in the last case here and adding 8 here, and that just returns 78. And then in the third case, before going to the third case, I'm going to multiply that 78 with the 10, and that just returns 718. And in the third case, I'm using that 780 here and adding 9 to that, and that just returns 789. So here finally we have gotten this 789. But if we observe the sequence here, and that is which is very important or to apply in programming, is not good. So to make it good, let us do something. Here in the first case, the first thing that we have done is that multiplication, and in the second case is addition and then multiplication, and in the third case addition. But if we follow this third case further, then we can also get that multiplication there. So our sequence is addition and then multiplication, but in the first case we are missing that. So I'm going to add this addition without disturbing any of these values. So what would be the number that is added to 7 in order to get the same value? Obviously that would be 0. So 0 plus 7 is equals to 7. So here is our sequence. First of all, we are considering 987 and then obtaining 7, and making our consideration number 98 in the same case, and then using the same process to obtain 8, and then we are making the consideration number 98, that is popping out the last digit, and finally we are using that 9 and making that 789. So let us apply the same thing in programming. So first of all, I do need a number, so I'm storing that 987 in a variable called num, and then I'm going to use the while loop in order to follow that sequence. So I'm using while loop here, and while num is greater than 0. So you can understand that soon while I'm giving that num is greater than 0. So here the first thing that we are going to solve is that num modulo 10, and storing that in a variable called a reminder. And then the second step that we have used here is adding 0 to that. So adding 0 to the number cannot make sense, because in the second case we have used that 70 and adding that. So here we are using the number from the last case and adding that here. So in the from the first case we have obtained 70, and we are using that in the second case, and in the second case we have gotten that 780, and we are using that in the third case. So as we have used the previous case number, we want 0 as the previous case number, but we don't have any previous case for the first case. So let us create a variable with the value 0. So a plus reminder is the value here, but we have to reuse this in the next case also, and that is having the same sequence. So I'm going to reassign that a plus reminder for a. So a will be equals to a plus reminder, and then the further step is multiplying that obtained a with a 10. So here we are going to multiply that a with 10 and equating that a to a. And in the third step we are going to do to decrease the number. That means we are going to pop out the considered number of the first case or the present case. So in order to pop out that, we just use the float division. So num float division 10 returns that. But in the second in or to continue this second case, this should be num. So I'm reassigning that value to num as this. So this will return the whole thing that we want. So here we have applied all the things correct, but let us consider the last case. It is ending with an addition, but after looping that last case also, in our process that is ending with multiplication. In order to avoid that multiplication, just we are altering the printing value. So here a is multiplied by 10 in the last case, so we are dividing that a with the 10. So let us run code. So here it returns 789.0. So here just if we want that as the int type, we are going to change the type to int. So you may have the doubt, we have not changed the type of this integer, but why is returning it 789.0? So that is because of this floor function, and we can use the same thing to detect whether a number is a palindrome or not. So I'm using if else statement to detect that, and if, or let us assign this value here as final. So here we have final, and if final is equals to num, we are considering here. But if we say if that is equals to num, here the value of num is 0, because after looping this, the last value of num is 0, and that is the reason why that loop is not executing once more. So we want the duplicate of this num, so I'm creating dup num and assigning num to that. So if final is equals to dup num, then just print that is palindrome, else just print that is not palindrome. Here we have missed that quotes. Yeah, that's it. So let us run it again. So here 987 is not a palindrome number. So let us enter 121 and let us rerun our program. That just returns that is palindrome. If you have any doubts, drop them in the comment section below.